Good morning everyone. So in today's class we are going to discuss about eraser on condition in JK flip-flop and also working of master slave JK flip-flop and also the different types of D flip-flop, T flip-flops. Okay, so with this class the operation of flip-flops is over. Okay, before going to discuss about various flip-flops, whether it may be JK flip-flop or master slave JK flip-flop, D flip-flop, T flip-flop. First, we have revised the last class topics. So, what is our last class topics? RS flip-flop as well as JK flip-flop. So, in RS flip-flop, how many number of inputs are there? 2 inputs are there. What is the name of the inputs? R and S. And how many number of outputs are there? 2 outputs are there. What are the 2 outputs? Q and Q bar. Okay. But in case of JK flip-flop, the inputs are indicated with J and K and the outputs are indicated with Q and Q bar. Okay. But in case of RS flip-flop, how many number of states are there with help of inputs? If we are applying 0, 0, predetermined condition is occurred. If we are applying 0 and 1, means S is equal to 0, we are getting normal output Q is equal to 0. If we are getting S is equal to 1 and R is equal to 0, we are getting normal output Q is equal to 1. If we are getting the normal output Q is equal to 1, that condition is called set condition. If we are getting normal output Q is equal to 0 by the application of input S is equal to 0, that condition is called reset condition. And the remaining two, means when both the inputs are same, either it may be low or it may be high, the output is not changed, that condition is called hold condition. What is the name of that condition? Condition is called hold condition. And see here, while coming to the RS flip-flop, here both inputs are high, there exists in hold condition, and that hold condition must be eliminated with help of JK flip-flop. How it will be eliminated? With help of JK flip-flop. If the JK flip-flop, when both the inputs are high, the output is not in hold condition, here the output is in toggle condition. What is meant by toggle condition? It is changed from 0 to 1 and 1 to 0, 0 to 1 and 1 to 0. So what is this condition? Toggle condition. So main drawback in RS flip-flop is hold condition when applying the same inputs are high. That must be eliminated in JK flip-flop. Here the output must be changed from 0 to 1 and 1 to 0. Otherwise both operations are there, both RS and JK having set condition and also reset condition. Okay, in set condition normal output Q is equal to 1 and in reset condition Q bar is equal to 1. And in both flip-flops having 2 inputs and 2 outputs. In SR flip-flop, SR considered as inputs, and in JK flip-flop, J and K are considered as inputs. And in both flip-flop common outputs are there, Q and Q complements. Okay, and means what? Here the two outputs are complemented to each other. And this is about RS and JK flip. And while coming to the last class, we are also discussed about 2 special inputs, clear and preset. What is the use of clear and preset inputs? If we are getting the output directly set or reset, irrespective of the previous stage inputs, okay, irrespective of the previous stage input, if I want directly, I want to set the output or reset the output, I am moving with what? Clear and preset input. Cause of clear and preset input means by applying the clock pulse across the clear input, the whole output of the flip-flop is cleared, means we are getting Q is equal to 0. Even though the main inputs are present, irrespective of the main inputs, if we apply the clock pulse across the clear input, the output is equal to 0. And if we apply the clock pulse across the presets, even though the main inputs are present, the output is equal to 1. That means what? By the application of clear and preset inputs, even though the inputs are present, the output must be produced according to clear and preset only. The output is set when we applying the pulse across the preset. The output is reset if I apply the clock pulse across the clear. Okay, this is about what's clear and preset inputs. Clear and preset inputs. Okay, and while coming to the next one, these inputs, clear and preset, are also called direct inputs. Why these are called direct inputs? Means what? With help of these inputs, the output is directly changed from 0 to 1 and 1 to 0. 0 to 1 and 1 to 0. So that's why these are called direct inputs. And by application of these inputs, the clock pulse means these inputs produce the output irrespective of the clock pulse. Even though the clock pulse is present, even though the clock pulse is absent, the output is produced according to this input. Means these inputs are not synchronized with the clock pulse, not depends on the clock pulse. That's why these inputs are also called direct, means asynchronous inputs. Okay, what are the two names of the clear and preset inputs? These inputs are also called asynchronous inputs and also called direct inputs. So this is about our last class. So now we see today's class topic is race around condition in JK flip-flop. So while coming to the JK flip-flop, first one is race around condition. What is meant? So in our last class already I told you, in truth table you see if both inputs are high, I think all of you are observed the condition. In truth table we are getting, if both inputs are high, the output or the state of the flip-flop is in which condition? Toggle. Already I told you what is meant by toggle. The output is trying to reach from 0 to 1 and 1 to 0, but not at all in either at 0 or at 1. The output trying to reach either the state 0 or 1, but not reach any level. In between 0 and 1 it is toggled. This condition is called what? Race around condition. Why? Because when both inputs are high in JK flip-flop, when both inputs are high, means when both inputs J and K is equal to 1, the output is changed from 0 to 1 and 1 to 0. Means try to reach the high level, but it is unable to reach the high level, so that it coming back and forth between 1 and 0. So this condition is called a race around condition. Why it is called race around condition? In presence of 1 and 1, if the inputs J and K is equal to 1, if J is equal to 1, K is equal to 1, the output tried to reach 1, but it is not able to reach 1, again it is at 0 only. If it is in 0, again it tried to reach 1. So it is back and forth in between 1 and 0. It is toggled back and forth in between 1 and 0. So this condition is called what? Toggle condition. This condition is called what? Toggle condition of the flip-flop. Is it clear what it called? Toggle condition. Okay. And also called what? Race around condition. Just like a race, it will try to reach 1, but it is again back to 0. It tried to reach 1, but it is again back to 0. So that this condition is called race around condition. Once I would like to read the slide. Listen. In JK flip-flop, if J is equal to 1, K is equal to 1, Q is 0. And when clock pulse is applied, then Q is equal to 1. This change takes place after a time interval delta t. So here this time interval delta t is called propagation delay. And now if J is equal to 1, K is equal to 1, Q is equal to 1, and if the clock pulse is still present, Q changes back to 0. So for the duration Tp of the clock pulse, the output will oscillate between 0 and 1. The output is oscillate between already I said you. That condition is called what? Race around condition. Here the output Q is ambiguous, means question mark. So this question is called race around condition. This race around condition is avoided when the propagation delay time is less than that of Tp. Okay, and this race around condition in JK flip-flop must be avoided with help of more one flip-flop. The name of that flip-flop is called what? Master-slave JK flip-flop. What is the name of that flip-flop? Master-slave JK flip-flop. Okay, what is the name of that flip-flop? Master-slave JK flip-flop. So it is specially designed to avoid the race around condition. What is the main theme of this? It is specially designed to avoid the race around condition in the JK flip-flop. So while coming to the diagram, see here it consisting of two parts. The name of the first part is called master flip-flop and the other is called slave flip-flop. So in logic diagram, it consisting of two main parts. What are the two main parts? First part is called master and the second part is called slave. What is the first part? Master. And what is the name of other part? Slave. And here the output of first flip-flop acts as a input for the next flip-flop. Output of first flip-flop acts as the input for the next flip-flop. Is it clear? Output of first flip-flop acts as the input for the next flip-flop. And main inputs are applied across the first flip-flop, that is to the master flip-flop. Main inputs. What are the main inputs? J and K. What are the main inputs? J and K. See here. So these are the prime inputs are applied to the first flip-flop. And once see here, these are the outputs of the first flip-flop are applied to the inputs of the next flip-flop. Okay, and see here the clock pulse must be applied to both the flip-flop but through a NOT gate. The clock pulse must be applied to both flip-flop. Master will receive the clock pulse and also slave will receive the clock pulse, but master will receive directly the clock pulse, but slave will receive the clock pulse through the NOT gate. So that indicate what? If master is activated with help of clock pulse, slave is in deactivated condition. Why? Because NOT gate provide complementing. Clock pulse applied to the master is high level, then it is applied to the slave is automatically low level. If clock pulse applied to the master is low level, that means if master is in deactivated condition, the slave getting high level clock pulse so that it moves into the activated condition. So in this way, the diagram consisting of two flip-flops. What is the name of the first one? Master flip-flop. And what is the name of the other one? Slave flip-flop. The master flip-flop must be having two main inputs and a clock pulse. The slave flip-flop receive the output of the first flip-flop as the inputs of the slave, and it also receives the clock pulse but after inversion only. For example, if master getting high level clock pulse, slave getting low level. If master getting low level, slave getting high level. So that means what it indicates? If master is in activated condition means slave automatically in deactivated condition. If master is in deactivated condition means slave is in activated condition. And finally, it having only two outputs. What are the two outputs? Q and Q bar. And what is the main theme of designing master slave flip-flop? To eliminate race around condition in the watch JK flip-flop. To avoid the race around condition in the JK flip-flop, here we are using or designing master slave JK flip-flop. Okay, is it clear? And see, this is the circuit diagram of master slave JK flip-flop. So how many number of NOT NAND gates are used? Finally, it having 9 NAND gates are there. Means it is the realization of master slave flip-flop with JK flip-flop. So here this flip-flop is called master flip-flop. So this is master slave JK flip-flop. So here how many number of NAND gates are used? 9 NAND gates are used. 4 NAND gates are used to design slave, and first 4 NAND gates are used to design master. 1, 2, 3, 4 and 5, 6, 7, 8 works for slave, and a 9th gate acts like a inverter. It will invert the clock pulse for the slave. Okay, clock pulse is directly applied to the master. For the master it is directly applied, and for the slave it is inverted and applied to the NOT gates. Okay, for the slave the clock pulse is inverted. And how many number of inputs are there? Main inputs, only 2 inputs are there. One is J and other is K, and clock is applied to both master and slave, but master it is directly connected, and for slave it is applied through the inverter. How many number of outputs are there here? 2 outputs are there. What are the 2 outputs? Q and Q bar. So this is the realization of or the construction of master slave JK flip-flop with help of NAND gates. How many number of gates here we are using? 9 gates. Okay, how many number of gates here we are using? 9 gates. Is it clear? Okay, so in this way the master and slave flip-flop, consisting of 9 NAND gates. Okay, and see, while coming to the truth table, see here, when J is equal to 0, K is equal to 0, again in JK flip-flop no change condition is occurred, and if J is equal to 0, K is equal to 1, Q is equal to 0, so that condition is called reset condition. And if J is equal to 1 and K is equal to 0, we are getting this. That means if 1 0 means that condition is called set condition. If both are high, if both are 1, then we are getting toggle condition. So this must be eliminated in master slave JK flip-flop like this. See here. So see here, See, if master is in set condition means slave is in deactivated condition. If slave is in active condition means master is in deactivated condition. So here once observe, if j is equal to 1, k is equal to 0, we are getting q is equal to 0. And if j is equal to 1, we are getting q is equal to 1. So see, for each and every clock pulse, when we are applying both 1 and 1, okay, race around condition will be eliminated. Race around condition will be eliminated. No change condition will be occurred. So no change condition will be occurred. Is it clear? Okay, coming to the slide, once check. When the clock is high, the master, already I told you, master is in active condition. When the clock is high, slave is in active and its output remains in previous stage. If the clock is low, master is inactive and slave is also in inactive condition. Okay, see. The next flip-flop is what? D flip-flop or delay flip-flop or data flip-flop. So here D flip-flop or data flip-flop has only one input. How many number of inputs are there for D flip-flop? In next flip-flop, one input is there. And here the designing of D flip-flop or aim of designing of D flip-flop is, it is used for storing the information. What is the use of D flip-flop? It is used for storing the information. And the output Q follows the input D after one clock pulse only. So here what is the name of the input? D. What is the name of the output? Q. So see here, the logic symbol first I draw here. So this is the logic symbol. So in D flip-flop, what is the input? D. Okay, in D flip-flop, what is the input? D. And what is the output? Q and Q bar. Okay, in D flip-flop, the input is D, input is indicated with D and output is indicated with Q. So what it inside contain again? SR flip-flop only. While taking SR flip-flop and connecting two inputs of SR flip-flop together. So once you check here like this, how can we construct? See, first you take one SR flip-flop having two inputs now, and you connecting together the SR inputs with help of inverter. By using one inverter, if you connecting two inputs of SR together, it will form which flip-flop? D flip-flop. So here the input is called D. So simply the D flip-flop also is made from which flip-flop? SR flip-flop. D flip-flop is also made from which flip-flop? SR flip-flop. In SR flip-flop, by connecting both and S inputs are together by placing or putting one inverter in between S and R. Means the same input is applied to S and R, but for S the input is directly applied and the same input is applied to the R through the inverter. Means what here, like master slave JK flip-flop, if S is equal to 1 means R is equal to 0. If R is equal to 1 means S is equal to 0 we are getting. Okay, and see, if D is equal to 1, simply Q is equal to 1. If D is equal to 0, simply Q is equal to 0. So that indicates what? Here the output follows the input. No modification is there. D1 means Q1, D0 means Q also 0. That's why this flip-flop is called data flip-flop or delay flip-flop. If D is equal to 1, the same will be produced at the outputs, but after the application of clock pulse only. So after the application of clock pulse means if I required the output 1 after 5 minutes, after 5 minutes only I applied clock pulse now. Okay, then only I get the output. Means here the output is delayed for some time. If I want delay, if I want to wait for some time, then D flip-flop is used. But the input is same as the output. Whatever the input I applied, I get at the outputs, but after some time. That time must be decided by the user. According to the user requirements, the clock pulse is applied. And here the D input will be transferred to the Q after the application of some delay only. Is it clear? This is also called delay flip-flop or the data flip-flop. Okay. So how many number of inputs are there here? 2 inputs. What are the name of the 2 inputs? S and R. Means it is derived from. It means D flip-flop is derived from SR only. But in SR, S is applied, R is applied differently. Here the same input is applied to both S and R by using inverter. If S getting 1, R getting 0. If S getting 0, R getting 1. But finally the input is only 1. If data is equal to 1, we are getting output is 1. If data is equal to 0, we are getting output is 0. That means what? Here the output follows the input. And what is the specialty of this flip-flop? What is called a delay flip-flop? The output we are getting after some time, after the application of clock pulse. So the delay depends upon the user. And it is also called a data flip-flop. Why? Means whatever the data we applied across the input, that is directly transferred to the output terminals. So that's why it is called data delay flip-flop. Okay. So see here, this is the block diagram or the logic symbol with RS flip-flop, RS inputs. It is the direct logic symbol of D flip-flop. Here it consisting of only D and clock pulse and the outputs Q and Q bar. But here it consisting of S and R and also the Q and Q bar. So this is the symbol that containing RS and it containing only the D and K. Okay. And see here, while coming to the truth table, this is the truth table. So clock pulse is 0 means even though the input is 0 or out 1, the output is not changed. See here clearly. D flip-flop is also synchronous. Why? Because if clock pulse is 0 means the D input is 0 also, the output is not changed. If clock pulse is 0, if D input is 1 also, the output is not changed. But in D flip-flop, the clock pulse is 1, if the input is 0, the output is also 0. So see here, in the application of clock pulse, if we are applying 0 across D, we are getting output Q also 0. But in application of clock pulse, we are applying the input 0, we are getting the output 1. Is it clear? So this is about what? D flip-flop. So in this way, the output will follow the input terminal. The output will follow the input terminal. So why it is followed? Whatever the output we are getting, that is equal to 0. If input is 0, output is 0. If input is 1, the output is also is equal to 1. So in this way, the output will always follow the input. One second. Okay. Okay, see here, next flip-flop is what? T flip-flop. What is our next flip-flop? T flip-flop. So here the name of the T is derived from toggle. Why? Because here the output is toggled in between 0 and 1, 1 and 0. So when T is equal to 0 is applied, means if input is 0, we are getting output is 1. If input is 1, we are getting output is 0. So why it happens means, like our D flip-flop, it is also derived from the RS flip-flop. But here both R and S are tied together. Both S and R are connected together. So cause of that, if we are applying R is equal to 1, we are getting Q is equal to 0. If we are applying R is equal to 0, here we are getting Q is equal to 1. That means the output is toggled. If we are applying 1, it is changed from 0 to 1. One second. If we are applying 0, the output is equal to 1. Okay. If T is equal to 0, we are getting output is equal to 1. If T is equal to 1, we are getting Q and bar. Okay. So in this way, the output is changed from 0 to 1 and 1 to 0. So say this is the symbol of logic symbol of T flip-flop. So it is also called toggle. Why? Because the output is changed. That is the complement of input. If I are applying T input is equal to 1, output is 0. If I apply T is equal to 0, the output is 1. See, here it is 0, we are getting Qn, means that is equal to 1. If T is equal to 1, what we are getting? Complementing is equal to 0. So once you compare the tables, both tables of D and T, see, in data flip-flop, if T is equal to 0, see, in data flip-flop or delay flip-flop, if D is equal to 0, we are getting Q is equal to 0. If D is equal to 1, we are getting Q is equal to 1. But in T flip-flop, D is equal to 0, we are getting Q is equal to 1. If T is equal to 1, we are getting Q is equal to 0. Here the output is toggled, changed from 1 to 0 and 0 to 1. So that's why this flip-flop is called what? Toggle flip-flop. Okay, and see here some questions are there. So these are the clock pulses of T flip-flop. Okay, if T is equal to 1, see, if T is equal to 0, we are getting Q is equal to 1 and Q bar is equal to 0. And in next case, if it getting 1 means T is equal to 1, Q is equal to 0 and Q bar is equal to 1. So in this way, the output is changed. The output is changed. It not follow the input. If it is equal to 1, means Q is equal to 0. If the input is equal to 0, the output is equal to 1. So it is clearly there. It is negative level triggering. So that at negative level, if it is 0 means Q is equal to 1 and Q bar is 0. Next, if it is 1 means, okay, if it is 1, it is 0 and again it is 0. Next time also, if it is 0, the output is high. Okay, like that. If in toggle flip-flop, whatever the input we are applied, we are getting complement for that input. We are getting complement for that input, not same will be produced. Okay, and see here, this is the comparison of our flip-flop. Before going to that, these are the different IC numbers used for production of flip-flop. So once see here, the first IC is what? 7470. Once you observe the slide, here all ICs are produced with 74 series only. So 7470 produced first one JK flip-flop, and 7472 produced master slave JK flip-flop, and 7474 will produce ULD flip-flop, 7475 will produce quad latch. Quad latch means 4 latches, either maybe NAND latch or maybe NAR latch, and 74109 will produce dual JK positive edge triggered flip-flop, and 74173 produce quad D flip-flop, and 74174 produced hex D flip-flop. Okay, and while coming to the CMOS flip-flops, here 74HC74 is there, and 74C74 is there, 74FCT374 is there, 74HC273 is there, 74AC273 is there, and also 4013, 40174 also will produce CMOS D flip-flops. Okay, which flip-flops? These are CMOS. And next 74HC7X, 74AC109 and 4027 produced CMOS JK flip-flops. Okay, CMOS JK flip-flops, and 4042, 4099, 74HC75 and 74HC373 produce CMOS latches. Okay, these are the different ICs, they produce the flip-flops. Different ICs, they produce the flip-flops. Okay, and once see here, these are the applications of flip-flop. These are the applications of flip-flop. First, while coming to the first flip-flop, that is SR flip-flop, it is used in switch debounces. Where it is used, debouncing means changed, position is changed from 1 to 0 and 0 to 1. So to protect the switch from debouncing means it is to hold in one particular condition. Here we are using SR flip-flop. Okay, and next SR flip-flop is used in memory storage devices. Where it is used, memory storage devices, and it is also used in counters. Okay, in memory storage devices, flip-flop is used to store the information. In counters, it is used to count the binary information. In JK flip-flops, okay, these are used in shift registers, binary counters, frequency dividers and sequence detectors. So what are the important applications of JK flip-flop? These are used in shift register to shift the data. Either the data must be moved from left to right, or the data must be moved from right to left. Next, the JK flip-flops are also used in binary counters. For the purpose of counting binary bits also, JK flip-flops are used. And these JK flip-flops are also used in frequency dividers. Okay, and these JK flip-flops are also used in sequence detectors. To detect the sequence, also the JK flip-flops are used. Okay, and see, these JK flip-flops are also used in serial to parallel conversion and parallel to serial conversion. So serial to parallel means, for the serial to parallel device, the data must be entered bit by bit only, but all data must be sent out at the same time. So once see the symbol, serial to parallel means it receives the input only with one way, but the output must be get outside at all the same time. For example, if 4 bits 0, 1, 2, these 4 bits entered one by one like this, these all bits getting out in 1 second only. Okay, means the data must be entered serially bit by bit, but the data must be taken out at the same time, whole the data. If it having 4 bit also, 8 bit also, infinite bits also, all the bits must be getting outside at the same time, where we are using our JK flip-flops. And JK flip-flops are also used in parallel to serial conversion. Parallel means number of bits entered into the register at the same time, but while leaving bit by bit must be leaved. Okay, while enter into the register, all the bits entered into the flip-flop at the same time, but while leaving the register bit by bit must be leaving. Okay, and while coming to the D flip-flop, data latches means where it is used. Data latches means to transfer the data from one place to other place, D flip-flops are used. And why it is called latch means latch simply connect one device to the other device. So here also the data flip-flops are used to connecting the data from one device to the other device. So that's why the D flip-flops are used in data latches. And these D flip-flops are also used in delay circuits. Why? Because in data flip-flops, the output must be produced after the application of clock pulse only. And like our JK flip-flops, D flip-flops also used in frequency divider circuits. Okay, next in JK flip-flop, T flip-flops are used in general binary addition devices. So means what? To add the binary numbers, T flip-flops are used. And like our D and JK, the T flip-flops are also used in frequency divider circuits and also used in binary counters. Okay, almost all common applications are there except JK having serial to parallel and parallel to serial, D having data latch, T having binary addition. These are the special applications. Remaining all are common. All are used in counters and all are used in and see. When coming to the multiple choice questions, the flip-flop which eliminates the racing condition effectively. Which flip-flop eliminates the racing condition? JK or D? JK flip-flop. The flip-flop, the preset and the clear data inputs are also called as. What is your answer? My answer is direct and asynchronous. So here synchronous or asynchronous? What is our answer? Asynchronous. Why? Because these input works irrespective of the outputs. Once you check the answer, it is clear. Yeah, it is correct. And see, while coming to the summary, today we have discussed about what? Revise the preset and clear input is there, and also master slave, JK flip-flop, D flip-flop, T flip-flop is also there. Okay, so in today's class, what are the topics? First one is what is meant by race around condition and how it is eliminated, and next topic is what is the need of JK flip-flop, and what is the main theme of master slave JK flip-flop, and next one, how can we design the D flip-flop and how can we design the T flip-flop. In master slave JK flip-flop, 2 flip-flops are used. First one is called master, second one is called slave. So first master will be activated, after it will produce the output only slave will be activated. Why? Because the outputs of the master acts as the input for the slave, and main inputs are applied to the master and the main outputs are connected from the slave. And clock pulse is common for both master and slave, but it is applied to the slave by using inverter. For master it is directly applied, for slave it is applied through the NOT gate. Okay. And while coming to the data flip-flop, here both inputs are tied together, but in between two inputs inverter is there. Okay, the output is whatever the output we are getting, that follows the input in data flip-flop. So then whatever the input we are getting, it is passed to the output. Why we are designing this means after some time it will give, means that's why it is called delay. If we want the same input after some time, then we are using our D flip-flop. Simply it store the information. Whatever the information we are giving to the D flip-flop, it will store that for some time and it will give the same to us as it is. Okay, it will give the same input as it is to us. So in this way it will store the information and it will give to us. And in T flip-flop it will provide the complements. If I apply the 1 input, it will give the 0, and if it will give the 0, then it will produce the 1. So in this way all the flip-flops must be worked simultaneously. Okay, with today's class the construction and operation of flip-flops will be over.